I'm Anil Kumar, and in this video we'll practice to write end behavior of a function from the given graph. So let me sketch some graphs. You can copy these and write down the end behavior. So we'll take a linear function first and let it be over the negative slope. So this time I'm taking a straight line which is going from quadrant 2 to quadrant 4. Now I'll take a quartic function which is degree 4. So degree 4 function, and let it start from here, and then let us say it goes kind of like this. So you need to write end behavior of this quartic function. Now we'll take absolute value function and let this be translated 5 units to left, moving downwards, kind of like this. And now we'll take an exponential function. So let the exponential function be a transformed exponential function which is reflected on the y-axis and is also translated few units up. So let me say this is 5 units up, right? So let's say this is 5, and let's write down, let me sketch a sinusoidal function. Let this function be kind of like this. Okay, so that is a sinusoidal function. Let's sketch few more. It's good to have some variety, and these ones are restricted on their domain. So this one is a square root function which is translated few units to left. I'll kind of label them also soon. Now another restricted function is the one which we have with horizontal and vertical asymptotes, which is a reciprocal function. So that is how it looks like. So let's say this is a reciprocal function, okay, and here we have horizontal asymptote which is y equals to, let's say, 1, and a vertical asymptote which is x equals to 2, let us say, and let me say this point is minus 3. Okay, here are two very interesting cases which are sometimes difficult to answer. So one is a horizontal line, let's say this is the horizontal line, the other one is a vertical line. So you need to write end behavior for these functions. Let's say this is at minus 2 and this is also at minus 2. So you need to write end behavior of these functions. So you can pause the video, copy these, and write down the end behavior. Here are solutions. End behavior really means you want to figure out what happens when x approaches negative infinity and what happens when x approaches positive infinity, right? So we need to find what happens to y values. I'm not repeating x approaches negative infinity and x approaches positive infinity, but I'll just write down what happens to the value of the function for these cases. Now in the first case, as x is approaching negative infinity towards this side, in that case y value approaches positive infinity. So we can write y approaches positive infinity, and when x approaches positive infinity, y approaches negative infinity. So we need to see the ends, right? Where are they moving to? Now in the second graph, both the ends are moving towards negative infinity. So you could write x approaches negative infinity, y approaches negative infinity, x approaches positive infinity, y approaches negative infinity. And it's exactly same here. So when x approaches negative or positive infinity, y approaches negative infinity. Do you see that? In this particular case, there is a difference. When x approaches negative infinity, the function approaches a value of 5. So y approaches 5. It is not quite 5. Do you see that? It is just approaching this value. When x is approaching positive infinity, then the function is approaching negative infinity. Here, end behavior cannot be defined, so undefined end behavior. Can you tell me the reason why? Now this function is sinusoidal, goes up and down within, let us say, plus and minus 1, but we don't know where exactly it could be at the end, right? End is not defined, so end behavior is not defined for such a function. Square root functions, the domain is restricted, so in such cases also we say only the behavior when x approaches positive infinity is defined. So when x approaches positive infinity, y approaches, as you can see, positive infinity. In this particular case, when x approaches negative infinity, y approaches this value, which is the horizontal asymptote, right? And which is 1. And when x approaches positive infinity, again it approaches the same horizontal asymptote, which is 1. It may approach from the negative value and the positive value. That's a different story. So sometimes we write this one negative as positive 1, approaching from top, and here approaching from bottom. So this is kind of helpful to sketch a graph. In this case, when x approaches negative infinity or when x approaches positive infinity, we know the value of the function is actually equals to minus 2, right? So since it is a constant, it is always minus 2. So when it is approaching, it is at minus 2. Vertical, this is not a function also. This is not a function, as you can see. It fails the vertical line test, and since there is only one point, it cannot approach negative or positive infinity. So in this case also end behavior is undefined. Do you see that? So these are a few cases where you can see that the end behavior is not defined. So they are very interesting cases. Sometimes you may get a question which maybe provide an example of a function. So if it is a function, then that's the one, right? This is not a function. Remember that this is not a function, okay? Where the end behavior is undefined, so it will be this one, okay? So I hope this video helps you to prepare for your test and try out some questions to be sure about this characteristic of the function. Thanks for your time.